Hello, welcome to you all in my channel Mechanical Engineering Concept. Today I am going to continue my previous topic, theory of elastic failure, in which we are going to discuss fourth number theory, elastic failure, which is maximum strain theory, or also often called Venant theory. Okay, so this theory predicts that this theory statement I am going to write now. This theory predict that the failure of the component, or mechanical component, we can consider failure of mechanical component of based on the strain at yield point. This theory has very simplified, very easy concept to understand. So for understanding of failure of the component can fail at strain when the yielding starts. Okay, so to understand better, now we need to consider a criteria. So I am considering here a biaxial stress condition in a component. Suppose this is a component in which we have stresses in x and y axis, sigma x, or we can consider here sigma 1, sigma 2 in y axis. Okay, so due to when we apply stress in x and y both the axis, the component will feel a Poisson effect, because if we pull the component in x axis, the component will feel stress in both x and y axis. It will elongate in x axis and contract it in y axis. Okay, it means in a x axis positive deflection will take place, positive deformation will take place, and in y axis negative deformation will take place. In that condition, we basically know we use a Poisson ratio or Poisson effect. Okay, this is we already discussed in strength of material. So due to that, the stresses in x and y we already know, and for that we can consider strain in x and y axis is equal to strain in x axis, or suppose I am considering x in this like this, epsilon 1 can be written as sigma 1 by E minus mu times of sigma 2 by E, and strain 2 will be written as sigma 1 2 by E minus sigma 1 by E into mu. Okay, if we simplify both the equation, we can take common in 1 by E from both the term. Epsilon E can be written as 1 by E times of sigma 1 minus mu times of sigma 2, and epsilon 2 can be written as sigma 2 minus mu times of sigma 1 by E in denominator. And as we know from Hooke's law, what Hooke's law states? Hooke's law says that stress is directly proportional to strain in elastic zone, or this theory is for elastic limit. So due to that I am using this concept. So sigma is equal to, can written as modulus of elasticity into E, Okay, so E can be replaced, E can be written as sigma by E. So for maximum stress, so here I am considering maximum stress sigma 1. Okay, so sigma 1 can be written as, from first theory of failure, SYT by FOS, maximum principal stress theory or Rankine theory for dimension calculation. This is the equation we already discussed. Or we can say that sigma 1 is equal to SYT for failure criteria, for understanding of failure criteria. This is the failure criteria. Okay, so sigma 1 is equal to SYT by FOS. So SYT can be represented as, sorry, sigma 1 can be written as epsilon by E is equal to SYT by FOS. Sorry, epsilon into E, my mistake. Here we can write epsilon into E. Epsilon into E. Okay, in place of epsilon I can write epsilon is equal to SYT by FOS into E. Put this epsilon here because this is the suppose I am considering sigma 1 as a maximum stress. Sigma 1 is more than sigma 2, assuming here. So in that case epsilon 1 will be more than epsilon 2. So epsilon 1 can be written as more than epsilon 2. So by which the equation of epsilon 1, which is epsilon 1 is equal to 1 by E times of sigma 1 minus mu times of sigma 2, can be written as, in place of epsilon 1, SYT by FOS into E, okay, is equal to 1 by E times of sigma 1 mu times of sigma 2. E and E cancel out from both the end. We can write it as SYT by FOS is equal to sigma 1 mu times of sigma 2. This is the equation for dimension calculation, for dimension calculation of a mechanical component. And if we wanted to understand the concept for failure criteria, then we need to remove this factor of safety. Then SYT can be written as SYT is equal to sigma 1 minus mu times of sigma 2. We consider factor of safety in case of dimension calculation only, okay, for safe design. For failure criteria we remove factor of safety. So this is the failure criteria for for maximum strain theory. So what does it mean? It means when the component has some strength, its material has some strength. Suppose SYT is equal to 50 megapascal is given to us, okay, and in that component stress, maximum stress is induced approximately around 100 megapascal. Sigma 2 induced is around 50 megapascal, consider approximately, and mu is given to us is 0.2 Poisson ratio, okay. So what does it mean? It means if we put the value in the equation, left hand side will be SYT is equal to come out as 50 megapascal and right hand side put the value sigma 1 minus mu times of sigma 2, then 100 minus 50 into 0.2, it will come out as 90 megapascal. It means left hand side value is less than right hand side. So this sigma 1 and sigma 2 is the produced value, or we can say the induced value in component, and this is the strength of the component for ductile material. So if we apply stress in a component more than the strength of the component, then component will fail. The component will fail. So for safe design, we need to take more strength, or we need to consider less amount of stress into the component. So for safe design, in case of maximum strain theory, we need to consider more strength than stress, or we can say that left hand side should be more than right hand side. Okay, so this is the major criteria for safe design. If the left hand side is equal to or less than right hand side, then only the component will fail. If the induced stress value right hand side, which is less than or equal to right hand side, if left hand side is equal to or less than right hand side, then the component will fail. If the left hand side, which is SYT, strength of the component, is more than the induced value of stress, then component will save. Further, now we need to consider what is the failure zone of the or boundary of the component. Before that, first we need to understand in which case the theory will use. The theory is applicable for both tensile and compressive stresses, and this theory is mainly preferred for ductile material. This theory is mainly used for ductile material. And one more important point, this theory is not very much used in practical application, because we know that we first study the maximum principal stress theory, which already cover this concept of maximum strain, because as we know that in elastic zone stress is directly proportional to strain. If we understand, if we able to calculate failure on the basis of stress, we can easily understand the concept of strain or maximum strain theory. Okay, due to that we didn't use this theory as much in a practical application. Okay, now the major part, SYT is equal to sigma 1 minus mu times of sigma 2. This is the theory. Okay, so for that we need to plot suppose this is the sigma 1 axis, sigma 2, sigma 1, sigma 2. Okay, SYT will be at each of the axis, SYT, SYT here, SYT, SYT. Okay, so here the equation, SYT is equal to sigma 1 minus mu times of sigma 2. So for calculation of that, first consider sigma 1 is equal to 0. If we consider sigma 1 is equal to 0, then if we consider sigma 1 is equal to 0, then minus mu times of sigma 2 will become what as syt, or sigma 2 can be written as minus syt by mu. Now if we consider sigma 2 is equal to 0, then syt is equal to sigma 1, which is representing this point, is each point. Negative means this is the negative point of sigma 2. Okay, so for that we can join them like this. Okay, this is the way we can join each of the point in this the way. This is the plot. Once again I am plotting this boundary condition. This is draw two parallel lines. First draw two parallel lines with same amount of slope, like this. Okay, with same length approximately. Join them like this. Erase this point approximately and join this point with this. So this is the approximate plot in which this is the axis of sigma 1, this is sigma 2, this is the safe zone, and this is the failure point. So safe zone can be represented here, safe zone, and this is the failure zone. So this depicted the region of biaxial system. This is the plot for biaxial system, biaxial stress system we can say. Okay, and this theory is mainly preferred for ductile material. This is the plot, and the equation once again I am repeating: SYT is equal to sigma 1 minus sigma 2 mu for understanding of failure criteria, and SYT by FOS is equal to sigma 1 minus sigma 2 mu will be the dimension calculation equation. Dimension calculation equation. I hope you understand the basic concept of maximum strain energy theory, maximum strain theory. In upcoming lectures of machine design, I am going to discuss the last theory of elastic failure, in which we are going to discuss about maximum strain energy theory, which is related to a strain energy concept. If you have any doubt related to this lecture, then please comment below this video and don't forget to subscribe my channel. Thank you. Have a good day.